All right, everyone. Welcome to today's Safety Explainer. I'm your plant safety manager, and today we're locking down our understanding of mechanical hazards to make absolutely sure everyone goes home at the end of their shift with all their fingers intact. Okay, let's just dive right into this. We're going to thoroughly examine the everyday risks associated with the heavy machinery out on the floor, and more importantly, how we safeguard ourselves against them.
You know, you might think a momentary lapse in focus around heavy machinery is no big deal, maybe just a close call, right? Well, just look at the sheer scale of destruction here. As this completely crushed truck demonstrates, unguarded raw power literally does not forgive. Whether we're talking about a massive piece of mining equipment or just the standard pressure workstation, machines operate purely on physics, not empathy. When flesh meets unyielding steel, the machine always wins, for sure.
So here is exactly what we're covering in this morning's briefing. We'll start with mechanical hazards on the floor, then look at how machines cause injury. From there, we'll identify the top 5 danger zones, discuss guarding and OSHA requirements, and finally, wrap up with risk assessment and maintenance.
Okay, Section 1, Mechanical Hazards on the Floor. Let's understand the threat.
So what are we actually dealing with here? Basically, a mechanical hazard is the fundamental danger posed by any power-driven machine, and it is the absolute reality you face every single time you step up to your workstation. Notice the definition here includes both automated and manually operated mechanical devices. Just because you're the one physically pulling a lever doesn't mean the mechanical force behind it is any less hazardous. It's still a threat.
Moving right along to Section 2, How Machines Cause Injury. We're looking at cutting, crushing, and breaking.
This comparison right here brilliantly illustrates the stark reality of our work environment. On one side, we have a massive, power-driven shear, the kind widely used in manufacturing to just slice through paper, metal, and heavy plastics. On the other, we have the incredibly fragile layers of human skin, tissue, and muscle. When you contrast that brutal, sheer power with our own anatomy, well, it's pretty easy to see why reaching under a blade to make a quick adjustment leads to catastrophic amputations. To put that into perspective, statistics show there are around 2,000 press operator amputations every single year. We absolutely do not want to add to that statistic.
Now, besides cutting, you really need to watch out for crushing injuries. These are incredibly painful, totally debilitating, and honestly super difficult to heal from. Crushing hazards generally fall into 2 buckets. First, you've got the squeeze point. This happens when 2 hard surfaces, where at least one is moving, push close enough together to just crush whatever's in between. Think of a hydraulic press. Second, we have the run-in point, which occurs where 2 objects, at least one of which is rotating, come progressively closer together and essentially pull you in.
And hey, let's not forget that beyond cuts, shearing, and crushed tissue, the sheer brute force of this equipment can easily snap bones like twigs. Depending on the impact and the specific machine involved, literally a single moment of contact can cause simple, compound, complete, or incomplete bone fractures. It happens in the blink of an eye.
All right, on to Section 3, the top 5 danger zones and what you need to look for out there.
Let's walk through the big 5 mechanical hazard zones on our floor. The absolute most crucial one is number 1, the point of operation. You must be hyper-vigilant here. That is exactly where the tool physically engages the work, where the cutting, shaping, or boring actually happens. Consequently, it's where the vast majority of our injuries occur. Following that, we have power transmission apparatuses, nip points, rotating parts, which by the way is any spinning mechanism like a spindle or shaft that can tangle you up, and finally, flying chips, sparks, or loose parts.
I really want you to deeply understand in-running nip points because honestly, these things are incredibly deceptive. These are the exact spots where an automatic feed or a gear mesh can grab a loose sleeve, a work glove, or even your hair and pull you right into the machine, way before you even have time to react.
Just take a look at these raw, unguarded gears and pulley belts. These are prime, real-world examples of power transmission nip points that will not hesitate to snatch your hand. Basically, anywhere a pulley meets a belt or where gears mesh tightly together, you have a dangerous in-running nip point. Okay, let's move to the next section and see how we actually build up a defense against all of this.
Section 4, Guarding and OSHA Requirements. This is all about stopping the threat.
Visually contrast these 2 setups. Look at the unguarded drill throwing dangerous, hot metal shavings right toward where an operator's hands would be. Now look at the safely guarded drill press right next to it, featuring a clean, electrically interlocked shield. Notice how incredibly controlled it is? Safety doesn't hinder your work, guys. It modernizes it.
It actually gives you the confidence to operate the machine efficiently without that constant fear of injury hanging over your head.
So these are the basic machine guarding techniques our plant uses. We rely on die enclosures, fixed barriers, adjustable barriers, and awareness barriers. But I really want to draw your attention to interlocked barriers. These are absolutely critical because they are literally wired directly into the machine's control system. The second an interlocked guard is opened, it completely disables the actuating mechanism. It acts as an automatic fail-safe shutdown switch. Also, actually, scratch that. Quick maintenance note here. When we secure guards, we do not use easily removable wing nuts. We use solid nuts and bolts, specifically recessed head fasteners like Allen screws, to ensure these guards cannot be easily bypassed on the fly.
We've also got some pretty high-tech presence-sensing devices on the floor, like these laser light curtains. This acts as a digital, totally invisible shield. If an operator's hand breaks the plane of those green lasers while the dies are closing, the system instantly stops the ram before anyone can reach into the danger zone. It's a phenomenal piece of modern engineering that keeps you safe without getting in the way of the materials you're working with.
And that brings us to Section 5, Risk Assessment and Maintenance. Let's talk about keeping the floor safe every day.
When assessing risk, please, don't just look at the paperwork. Use this simple fault tree logic. This is exactly the framework our safety and maintenance teams use to investigate near misses. It's like a giant puzzle. You start with the top event. Let's say a machine lost power unexpectedly. Then you trace the faults backward to find the root cause. Maybe a clogged filter caused a power supply failure. Finally, you implement a permanent countermeasure, like scheduling a monthly filter cleaning. We track down these root causes before a real accident actually occurs.
Now, listen up, because this applies to every single person working the floor. I want every operator using this simple, daily safety checklist to verify your workstation before you ever even think about hitting that green button. Check your point of operation guards, inspect those power transmission covers, ensure the electrical interlocks are actually functioning, verify you have the proper PPE for flying chips, and absolutely confirm you have zero loose clothing, dangling jewelry, or untied hair anywhere near those rotating parts.
And when it comes down to maintenance shutdowns, you need to understand this. Bypassing lockout/tagout procedures isn't just some minor rule break, it's huge. Nearly 80% of alleged lockout/tagout violations are classified as serious by OSHA, which accounts for millions of dollars in penalties annually. But forget the money for a second. It is deadly serious, because starting up a machine while someone is inside making an adjustment is a fatal mistake, no exceptions.
Which leads perfectly to the ultimate goal for our plant maintenance team, achieving a zero mechanical state. What does that mean? It means a complete 100% shutdown of all energy sources prior to any maintenance. We're talking absolutely no pneumatic pressure, no hydraulic pressure, no electrically charged capacitors, no spring tension, and zero kinetic energy left over from a spinning flywheel before you ever reach into that machine.
So I'll leave you with this. Before you head back out onto the floor today, I want you to look at your workstation, look closely at your machine, and honestly ask yourself, are you truly at a zero mechanical state before you do maintenance? Are your guards properly locked in place? Or are you leaving your safety, your livelihood, and your physical well-being entirely to chance? Thank you all for your time, stay sharp out there, and let's have a safe shift today.